A chemical reaction is shown 2 moles of nitric oxide plus 1 mole of oxygen giving 2 moles of nitrogen dioxide. How many liters of pure oxygen gas measured at STP are required for the complete reaction with 8.82 liters of nitric oxide, also measured at STP? Key point here in this problem is that everything in this equation is in the gaseous state. In particular, the 2 reactants that we're concerned with in our problem, nitric oxide and oxygen, we're told that we have 8.82 liters of nitric oxide, and we want to know how many liters of pure oxygen do we need to react with that. The 2 reactants are in a gaseous state, and because they're in a gaseous state, Avogadro's law applies, which says that the volume of a gas is proportional to the number of moles. Plotting that as I did in lecture, if we have moles on the x-axis, volume on the y-axis, we get a straight line, a linear relationship between the two. Therefore, the volume of the gases will be proportional just as the moles. So looking at nitric oxide and oxygen, we can write up 2 ways of expressing the conversion between these two. We can say 2 moles of nitric oxide equals 1 mole of oxygen. Recall we did mole-mole conversions earlier in the semester, and this is the way we approach this relationship. But since these are both gases, we can rewrite this and say 2 liters of nitric oxide is equal to 1 liter of O2. And we can say that not only because both of these are in the gaseous state, but more importantly, we are not changing the temperature or pressure in this reaction, therefore the volume cannot change. As such, we can therefore use this latter equation for a conversion factor since we're given a volume of nitric oxide. So we're going to do this in our usual way. We're going to do this exactly as a mole-mole conversion, except we're using liters. 8.82 liters of NO. Now, since we want liters of oxygen, my conversion factor is circled. I want liters of NO downstairs, so I've got 2 liters of nitric oxide downstairs, 1 liter of O2 upstairs. My liters of nitric oxide cancel, and let me give myself a little bit more room here to do the math or write the answer. So we can divide 8.82 by 2 in our heads, and we get 4.41 liters of O2 would be required for complete reaction of all the NO given.